variable.
Okay, so now we're going to continue
Once
the
you do
notes
that
we started
subtraction,
in class
you
last
square
time.
that number,
Today we're going to talk about the
multiply it by its
variance
probability,
and how it relates
and
to
then
the standard
take
deviation.
that for every
we're going to learn
single-
how to
do that
calculate
process
the
for
variance.
every variable.
So you can see here
in
that
every
the
random
relationship
variable in the
with the
problem,
variance
and then add
of
your
a
answers
random
together.
variable and the
Once
standard
you
deviation
that
of
answer,
a random variable,
then take the
is
square root of it,
the
and
same
you get the standard
relationship that it
deviation.
was when we were
I
dealing
think
with
it's easier
quantitative
to
data.
learn this
if
if
you
we
square
look at
the
an
standard
actual
deviation,
problem.
you can get to the
So
variance.
I want you to remember the corner bet
Now the
problem that we
formula
looked at
is
in
slightly
class.
different.
The
For the
first thing that
formula,
we
we're
have
going
to
to
do
take
when we
the
find
value
a
of the
standard
random
deviation
variable
is we
and
have to find the expected value,
the
or the
expected
mean
value
variable.
from it, or the mean
In
of
this
the
case,
random
for the
variable.
corner bet
They mean
problem,
the same
that
thing.
value
Once
was
you do that
negative
subtraction,
5 cents.
you square that number.
Now, if you remember our
multiply
table,
it by its
the
probability,
table was
and then
constructed
take that for
because
every single
if
do
you
that
played
process
a dollar
for
bet,
every variable.
there were two possible
in
outcomes
every
for
random
winning
variable in the
this
problem,
game. You could win
and then add your
$8,
answers together.
or you could lose
Once you
your dollar.
get that answer,
If you won, you
then
had a
take the
4 out
square
of
root of
38
it,
chance
and you get
of
the standard
winning
deviation.
$8, and you
I
had a
think it's
34 out
easier
of
to
38
learn this
chance
if we
of
look at
losing
an
your
actual
dollar.
problem.
So
I
to
want you to
calculate
remember
the
the corner bet
variance
problem that we looked at
we're
in
going
class.
to take the first
thing that
which
we
is
have to
8,
do when we find a standard deviation
subtract
is we have to find the expected value, or the mean
the
of the
5
random
cents. Now
variable.
remember, the 5 cents
In
is
this
already
case,
negative.
for the corner bet problem,
So we're
that
subtracting
value was
the
negative 5
expected
cents.
value, which is
Now,
the same
if you
thing
remember
as
our table,
subtracting
the
a
table
negative expected
was
value, same thing as
constructed
adding the
because
expected value, so you
if
get
you played a dollar
$8.05.
bet, there were two possible outcomes for winning in this game.
Now, you
win
could also
$8,
lose your dollar. So there's the
or you
negative
could
1.
lose your dollar.
We're subtracting the
If you
expected
won-
value.
you had a
and we
4
got a
out of
lot of
38
subtraction
chance
signs
of
floating
winning
around here, and it's easy to lose
$8,
one.
and you had a
so
34
make
out of
sure that
38
you know that you're
chance
actually
of losing
adding
your dollar.
because subtracting
So
a
to
negative,
calculate
same
the
thing as adding.
variance,
and now we have
we're going
1
to take
minus 5
the
cents,
first
which
number,
is negative
which is 8.
95 cents. Subtract
All right, now we're going to square that number as well.
the 5 cents. Now remember, the 5 cents is already
So
negative.
now let's see what
so
these
we're
add up to.
subtracting
Well, if we come over
the
to our
expected
calculator,
value, which is the same thing as subtracting a negative expected
and
value.
we
Same thing as
calculate,
adding the
we
expected
turn the
value. So you
calculator on,
get $8.05.
and we have $8.02. $8.05.
Now you could also lose your dollar.
Squared.
So there's the negative 1.
Plus.
We're subtracting the expected value. Now we got a lot of
Negative
subtraction signs floating around here, and it's
95
easy to lose
cents.
one. So make sure that you know that you're
And add
actually
them together,
adding.
we get
Because subtracting a negative, the same thing as adding. And now we have 1 minus 5 cents, which is negative 95 cents.
This is the variance, remember.
All right, now
We're going to square that number as well of the random variable.
So
to
now
find the
let's see
standard
what these add up
deviation of
to.
the random variable,
Well, if we
would
come
have
over
to
to our
take the square
calculator,
root of 6390, and we calculate, we turn the
Back to the
calculator on, and we
square
have
root
$8.02, $8.05 squared. We got an error. Plus, let's try it again. Negative of 95 cents. And we get
Squared.
and add them together,
$7.99.
we get 63.90.
All right.
Now, this is the variance.
Now I want you to
remember.
take a few minutes, and I want you to calculate the standard
The random
deviation of the
variable.
National Hockey
So to find the
League
standard
example.
deviation of the random variable,
And I'll give you a
we
few
would have to
minutes to
take the
figure
square
that out.
root of 6390. Back to the calculator. Square root of 6390. We got an error. Let's try it again. Square root of 6390, and we get $7.99.
All right. Now I want you to take a few minutes, and I want you to calculate the standard deviation of the National Hockey League example. And I'll give you a few minutes to figure that out. All right, so now there's a much easier way to do this, and that's if you use your calculator. So
the way that we would do this is the very first thing we would do is put, in list 1, we would put all of the values of the random variable. So list 1, values of random variable. In list 2, we'd put the corresponding probabilities.
All right,
And
so now
then,
there's a much
we would
easier
graph
way
the histogram.
to do this, and that's if you use your calculator. So the way that we would do this is the very first thing we would do is put, in list 1, we
And
would put
then
all of the
do
values
one
of the random
variable.
variable. So list 1,
Stats.
values of random variable. And that would give you your stats on your random variable. So let's take a look at it. So
In list
we're going to
2,
switch back to the
we
to
put
the
the corresponding probabilities.
problem for the National Hockey League. You see the boxes on my kitchen table. There we go. All right, so now we're going to take this and we're going to put the numbers
we would graph the histogram.
into the calculator. So I'm going to turn my calculator on. Well, it's already on. And I'm going to put these numbers in. So you put these numbers in your calculator as I'm putting them in mine.
And then
Don't forget that
variable.
you may have to clear your calculator
Stats.
out if you already have numbers in. So in list 1, I'm going to put in the numbers 0 through 9.
And that would give you your stats on
your random variable. So let's take a look at it. So we're going to switch back to the probabilities problem for the National Hockey League. You see the boxes on my kitchen table. There we go. All right, so now we're going to take this and we're going to put the numbers into the calculator. So I'm going to turn my calculator on. Well, it's already on. And I'm going to put these numbers in. So you put these numbers in your calculator as I'm putting them in mine. Don't forget that you may have to clear your calculator out if you already have numbers in. So in list 1, I'm going to put in the numbers 0 through 9. Okay, once you have all the data in, go to stat plot, and in list 2, I'm going to put in the probabilities. Go down, find the histogram. Your X list is in list 1. Your frequency is in list 2. So you have to change that over to list 2 and then zoom 9. Well, and we didn't get the right graph. Let's see. Okay, once you have all the data in, go to stat plot, turn your first graph on, go down, find the histogram. Your X list is in list 1. There we go. Okay, so what I did is I changed the frequency to 1, and so then when I zoom 9, I get the same bar that I did. Doesn't look exactly like what we did in class because our class had 9 bars. This is combining some of them, but it'll give us the right information for the variance and the standard deviation, which is what we're looking for. So if we go to stat, over to calculate in one variable statistics, we find that the standard deviation is going to be 2.87. So the standard deviation is 2.87. So we write that down. Standard deviation of our random variable x is 2.87. And then to find the variance, we square 2.87, and that gives us our variance. So if we take 2.87
to the second power. We get 8.2369. And that's how you work that problem out. Are there any dangers to be aware of when calculating? When using the calculator to find the mean and standard deviation of a discrete random variable? Well, yeah, there is. The students on the AP exam lose credit for not showing work. So for these, you want to do just like what I showed you in class, where you want to show that you know how to calculate the standard deviation and variance for one of the values at the beginning and one of the values at the end, and you can put 3 dots in the middle. Let's go back that you have to make sure to show your work, and you want to show your work the way that I showed you in class. All right, now continuous random variable. That's where we're going to go on from here. So what is the difference between a continuous random variable and a continuous random variable and a discrete random variable? Well, the continuous random variable is anything that you have to measure. For example, foot length, the length of a person's foot, or maybe shoe size. The difference between the discrete and the continuous is that between a discrete random variable entries, there are no gaps. So you're counting whole numbers like 1, 2, 3, 4, 5. Whereas a continuous random variable goes through all of the fractions that are between the two numbers on the graph. So you might want to know the time it takes to run a 100-meter hurdle versus the number of hurdles that you might have taken, that you might have had to jump, or the probability of any event happening as an area under a curve, which we're about to get to. So those are some examples of a continuous random variable. All right. How do you display a continuous random variable? Well, we would display the continuous random variable with a normal probability graph, and that's what we're about to do in just a few minutes. All right, let's go ahead and take a look at a problem, and I think that will help us figure out what we're supposed to be doing here. So in this next problem, it's the weight of 3-year-olds, and it says the weights of 3-year-old female follow the normal distribution curve with a mean of 30.7 pounds and a standard deviation of 3.6 pounds. Randomly choose one 3-year-old female and calculate her weight. So we want to find the probability that the randomly selected 3-year-old female weighs at least 30 pounds. Well, we've done this before. So we're just going to now formalize it with the probabilities. So we want to find the probability that the randomly selected female weighs greater than 30 pounds. Before we were just trying to find the percent of girls. Now we're finding the probability that the female has weight greater than or equal to 30 pounds. So what are we going to do? We're going to draw a normal curve, just like we always did. And for our normal curve, we need our mean and our standard deviation. So that would be 30.7, that's the mean, and the standard deviation of 3.6. So the first thing we do, find the z-score. We do that by calculating z equals x sub I for our first
random variable minus our expected value divided by the standard deviation. We just plug in the numbers. Here we have 30 minus 30.7 divided by 3.6, and that equals negative 0.19. All right, then we're going to draw our picture. So 1 is to calculate this. 2 is to draw the picture. So we're going to draw our normal curve. It's normalized, so 0 is in the middle. And we have negative 0.19, so that's our z value. So negative 0.19 is just, negative 0.19 is just a little bit to the left. Then we have to decide how much to shade on each side. So how do we do that? We use our table. So we use z table. To calculate the amount. When we look it up on the z table, we find that we have 0.4247. Take a few minutes and look that up on your table. Verify it for yourself. But remember, we're looking for the probability that z is greater than or equal to negative 0.19. Remember the original problem when we were looking for the random variable? Before we normalized it was greater than. Now that after we've normalized it, now we turn it into a z, but it is still greater than or equal to. So that means we subtract everything from 1. So we have 1 minus the value we found in the table, and we end up with 0.5753. Now we have to interpret that value. So the interpretation is where the most important part of this problem is. Interpreting it, we would say there is a 58% chance, because I'm just rounding it, that a randomly selected female and the female's 3-year-old will weigh at least 30 pounds, because that's what we were looking for. All right, what if we wanted to find, like in the next question, where a randomly selected female was between 25 and 35 pounds? Well, now we're going to do that z-score twice. So we're going to use 1x for 25 and 1x for 35, and then find the z-scores for each and subtract the areas. So to convert these to z, we have our 25 minus our 30.7, which was the mean, and they told us the mean back up here in the problem, divided by 36, which is with 3.6, which is our standard deviation, and that comes out to be negative 1.5833. Then we have the z for our 35, so we have 35 minus 30.7 divided by 3.6, and that becomes 1.1944.
we look those up on the table, and we find that where Z is less than 1.5833, on the table it says 0.0571, and for Z being less than 1.1944, we look it up on the table and we find that its value is 0.8830. Then we take these two values and we subtract them. So 0.8830, because we're looking for the value between. And when we subtract them, we end up with 0.8259. So there, when we write our conclusion, there is about an 83, because we round that to 83% chance that a randomly selected 3-year-old will weigh between 25 and 35 pounds. And that's how you find that one. So what if they gave you a problem that looked like this? How would you find the value that they're looking for? Well, this number right here is in the number in the Z table. So we're going to use the Z table to find it. To find that Z-score. All right, so if we look on the table as close as we can to find a number that is 0.8, then if we go to the outside edge, we should find a Z. I'm going to go as close to 0.8 as you can find. You're going to find the Z to be 0.84. Now, when Z is 0.84, now we can substitute that into the Z formula as Z. We don't know X. We don't know the random variable. The random variable is the value we're trying to find. So we'll leave that one as X. And then we'll subtract 30.7 from it, the mean given to us in the problem, divide by the standard deviation, which is 3.6. Do some algebra on it by cross multiplying and then adding. We find our X is equal to 33.724 pounds. And now you should have enough information to be able to do your homework. See you tomorrow.